Okay, so yeah, this is just calculator AP3. Let me just first show you how to crank these out in the calculator. We'll get to what they are real life in a second. But first off, how do you even get the numbers? Just to hit the buttons on the calculator. Hit 8 first, and then hit the math button. I'll write the instructions here. Math, which is on the left side. So first do the 8, and then hit the math button. And go all the way over 3 times to the PRB, which is probability menu. And go down until you see the NPR. Stands for National Public Radio. No, not in this case. NPR is it's a probabilistic thing. It means permutation. Yeah, that's what it means. NPR. Hit enter, and that'll put the P on the screen, and then hit the 3 and hit enter, and you should get, I don't know what it is. 8 times 7, 56. What is it? 336. 336. Y'all getting that okay? On the graphing calculator. I'll show you how to do it by hand as well if you want. It's not that hard. If you want to do it by hand, or I mean just with a simpler calculator where you don't need to use everything, the first number is where you start at, and 3 is the number of numbers. In other words, you start at 8, you multiply 3 numbers together. That's what it means. 8 times 7 times 6, 336. That's all it's doing for you. Start at the first number, and the second number is how many numbers. So start at 8 times 7 times 6, 3 numbers. Start at 8, do 3 numbers. 8 times 7 times 6, same answer. You can just do it that way. Is that good? That works. That does not give you the same answer? Let me check. Yeah. Okay, so ready for number 2? We good? You all able to get that in your calculator one way or the other way? That's combination. This section is all about permutations and combinations. So now the C, same kind of thing. You just do 11, and then you hit math, and go all the way across to the PRB menu. Go down to the NCR, combinations, and hit enter. And then put in the 4 and hit enter. I don't know what that is. So 11, math. 330? Y'all getting that? 330? If you're interested in the by hand method, it's the same. You start at that, and how many is the 4? So you start at 11, 10, 9, 8. So you start at 11, do 4 numbers, just like the P, but the difference is with the C, you cut. That's my little memory device. You divide by the second number all the way down to 1. So you can just use the buttons on there. You can just do the NCR if you want on the calculator. But that's how you would do it by hand, if you wanted to do it by hand. So it's just like the P. The top is just like the P, but you do have to cut it, divide it by the second number all the way down to 1. That's 4 factorial. That's what that is. Have you seen that before? So that should come out the same. Yep, that is. That's 330 also. Does that make sense? Second number down to 1. 4, 3, 2, 1. We good? We exceedingly happy about that? All right. So it says 9P1. How do we do that? What do we start with? Start with 9, do 1 number. Done. 9. Your calculator will tell you that too. All right? All right. We good? Easy enough? I can't remember. What's that? That's like 6.
I'm excited.
I am so excited about that 6. What is that thing? It just means start at 6, go all the way down to 1. Multiply. It's called factorial. I'm not going to quiz you on the names. It's 6 factorial. Factor means things multiplied. So it's just 6 all the way down to 1. There's a button on your calculator if you want to do it on the calculator. It's under math again. It's under math, probability, go down, there's a button. And you can find it. You just go 6, then hit math, go over to probability, down to the exclamation point, and you'll get 720. It's amazing it gets that big, that fast, isn't it? I wouldn't guess it was so big. Is that good? So it just means all the way down to 1. C2, you guys got your calculator? So you can crank it out. Let's see who's got it first. What's the answer? 105. See if you can get it. You can do it by hand or by calculator. 15C2. All getting that okay? 15C2. All right, I'm going to move on. Assuming. Okay, the owner of a stereo store wants to advertise that he has many different sound systems in stock. The store carries 6 CD players, 10 receivers, 7 speakers. Assuming a sound system consists of one of each, how many different sound systems can he advertise? How many different setups are there, in other words? That's the funny math class up there. So, you have any ideas? What do you think about that? There's 6 CD players, 10 receivers, 7 speakers. How many different total configurations? How would we figure that out? Let me start with a simpler question, and then we'll build up to this one. What if I said, hey, I'm going to, when I get dressed in the morning, I have 2 pair of pants that I can wear and 3 different shirts. And that completes my outfit. So how many different total outfits? 6, huh? You could just multiply 2 times 3 is 6. If you're unsure that that's really right, you could see it's really true with the tree. You know, of course, you don't have to. You can wear pants 1 or pants 2. And then you can, if you wear pant 1, you can wear shirt 1 with it, or shirt 2 with it, or shirt 3 with it. Or if you wear pants 2, you can wear shirt 1 or shirt 2 or shirt 3 with that. So there's 6 different total options, aren't there? So you just take that number, multiply that number, huh? That's all you got to do. So what if I also said, oh yeah, and there's 2 different shoes. I have 2 different pairs of shoes to wear. What would that do to the total number of outfits now? Well, I said it, no, I multiplied. You multiply, you would go, because there'd be 2 different options for shoes. For each of these outfits, you double it. Because there's 2 options of shoes now. And if then they say, oh yeah, and then there's 3 coats. I have 3 different coats. Well, then each of these would branch off 3, and you'd multiply by 3. So you see, every time you make a new item in the problem, a new decision, another decision, like what pants am I wearing, what shirt, what shoes, what coat. Anytime you make a new decision, it just multiplies the different possibilities, because it's just a tree branching bigger and bigger, isn't it? So all you got to do is multiply those. So that's all that's really going on here. So you've got to pick a CD player. There's 6 of those. You got to pick a receiver. There's 10 of those. And you got to pick a speaker. There's 7 of those, and you times these together. So easy way, 6 times 7, 42 times 10, 420. You just calculate that, 420. 420, so they can advertise, we have 420 different sound systems. Sounds so impressive, doesn't it? But really, they just have 6 CDs, 10 receivers, and 7 speakers. But there's 420 different ways those things can go together. Make sense on that? I call that decisions and options kind of thinking. We have to make, like if you were going in there to pick a sound system, you'd have to make your first decision, which CD player am I going to get? There's 6 options. Your next decision, which receiver am I going to use? 10 options. Your third decision, which speaker? 7 options. So every decision, you just put the number of options and you multiply them. Okay. Company wants to have 3-digit phone extensions with the first digit not being 0. How many different extensions are possible? Wow. So say you got a huge company. It involves, there's offices in 23 cities across the United States, and they want to set up this phone system that'll connect them all together. And they're thinking, okay, we're going to use a 3-digit phone extension. We don't like the first digit being 0. That'd just be weird. No 0 in the front. And how many, will this cover us? Will this give us enough different extensions for all our employees and all the different branches of our company? How many options for different phone numbers, extensions, will that give us? Real life, practical kind of question. This area where we just entered an area, we just entered an area of math called counting. Now that just sounds babyish, doesn't it? Counting. Did that when I was in preschool. 1, 2, 3. But that's technically what we're doing. We're counting how many different extensions are possible, aren't we? I took a whole class on this when I was at Cal Poly. This is way after calculus. It was a junior level math class in the math major called counting theory. I remember I saw it, it looked easy. Counting theory, all right. I'm looking for an easy one. That class was so hard. It was really hard. Because it gets subtle. I don't know if we'll see it much. You get up there, it gets really tricky to correctly count the number of ways something can be done. I had Dr. Hood for that class. I had him for several classes. He was always very challenging. And I remember that it was so, here's how I give you a feel how hard that class was. For the final exam, Dr. Hood gave us the questions ahead of time. Double the number of questions. Like, I think he said the final would be like 10. He gave us 20 questions. They were paragraphs, word problems. And he said, all right, here's the final. He said, I'm going to pick 10 of those 20. No changes at all. Literally. 10 of those 20 will be your final exam in a week. Figure those out, see you in a week. That didn't help. They were hard. I mean, they were really hard. I did not get an A. I remember working on those and thinking, this is hard. It gets very subtle. So, but not too bad here. Think decisions and options. Think decisions. One thing I learned in that class that helped me is I learned to be real. I mean, I learned that in a lot of math and science classes. The more real I was about things, the better my thinking would actually be. That you couldn't think as well as you think you can think if you're not real with it. What do I mean real? Let's pick one. Let's really make one up right now. That'll help you. The more, it'll get your mind concrete, which helps. So now let's pick one phone extension. Suppose you're going to have an office. Let's pick your phone extension. Here we go. Somebody got one? 1, 2, 3. Great. That works? That's a possibility. Okay. So 1, 2, 3. Then think back. How many decisions did we, to pick one, how many decisions did we just make? We made 3 decisions. We decided, didn't we? Right? So when I made the first, and then so we're going to go options, multiply options, multiply options. Can you read my scribbly writing there? Options times, that looks terrible. Options times options times options. Options times options times options. So that's That's how you do at least these introductory level ones. You just think how many decisions, and then and how many options for each decision, you just multiply those together. So when I made the first decision, or one of you made the first decision, and you chose the digit 1, you could have chose other things for the leading digit. How many options did you have for that leading digit? How many different things could you have picked from? 9, not 10, huh? 1 through 9. Any of the numbers 1 through 9 would have been fine. Couldn't use 0, because they said don't start with 0. Right? Right here. First digit, not 0. Okay, for your next decision, we chose 2. How many options did we have for our second decision? 10. Now 0 is in the ball game. 1 through 9 and 0. We could have chosen 103, couldn't we? That would be a valid phone extension. Right? Now we have 1 through 9 and 0. That's 10 options for the second digit. You agree with me? And for our third decision, we chose 3. How many options did we have there? 10 again. 1 through 9 or 0. 10. So 10 times 10 is 100 times 9, 900 extensions. There'd be 900 different extensions possible if you go by those rules. No 0 in the front, 3 digits. 900 different possible phone extensions. Make sense? Decisions and options. License plate tags in a particular state are to consist of 2 letters followed by 3 digits with repeated letters and digits allowed. How many different license plate tags can there be in the state? You see, when people set up big systems like this, zip codes, phone numbers, license plates, they've got to make sure the plan they have with letters and digits or whatever is going to have enough options to cover all the cars in the state of California that will ever exist, right? Or all the phone numbers in a county, or all the, etc. You got to make sure you're covering enough options. If they just said, hey, we're going to make the license plate be 1 letter followed by 1 digit. Well, they're going to run out of options, right? They're going to be having people with the same license plate. And then somebody's going to commit a crime with a license plate the same as yours, and they're going to take you to jail. Say, well, it's your license plate right there. Right? We can't have that. So you got to have a system that has enough. So if we're going to do 2 letters, what's the plan? 2 letters followed by 3 digits. How many different license plates is that going to cover? So you want to count them. This is a counting question. Let me give you a second. You'll get more out of it than if I just whip it out. What am I going to say you do first? Be real. Pick one. Pick a license plate right now. So don't jump into all the math. You'll do much better with math once you've been real with what they're talking about. So pick an actual one. Pick a license plate. Pick 2 letters and 3 digits. And then think back to how many decisions you made and how many options you had for each decision. By the way, how many letters in the alphabet? 26. 26 letters in the alphabet. Going to need that fact. 26 letters. All right, so let's pick one. Somebody got one? Give me a license plate. AB. Well, here's my old license plate. I used to have a 280Z when I was in college. I had a cool car. Now I drive an old family van. I used to be cool back in the day. No, I wasn't cool. But I drove a cool little car, and I sold it when we got married. But anyway, 365, I still remember my old license, 365 TVP. Let me just cut off a digit because we're only allowed to do 2 digits. So I'll just go with that license right there. That license is 65 TVP. There we go, 65 TVP. 2 letters followed by 3. Oh, no, I got it backwards, don't I? Yeah. That's just crazy. What am I doing? That isn't right at all. So 2 letters. All right, so how about GW, 3 digits, 704. There we go. So 2 digits 2 letters followed by, that's not how it's bugging me. It's not how they go. But anyway, 2 letters followed by 3 digits. All right. How many decisions did I make? 5 decisions. I decided a letter, decided a letter, decided a digit, decided a digit, decided a digit. For each of those decisions, let's think about how many options. When I decided G as my first letter, how many options did I have for that letter? 26. There's 26 letters in the alphabet, right? Could put A, B, C, D, E, F, G, H, I, J, K, all the way through to Z, right? When I made my next decision, how many options? 26, right? Could be any letter again, right? Times. Now, when I decided my next spot, it was a number. It was a digit. How many options? 10. 1 through 9 and 0. Right? They didn't say anything up there about no 0. That's why I even purposely put a 0 in, just to make sure you're clear. 0's okay. 1 through 9 and 0. That's 10, isn't it? And 10 and 10. Multiply those together. I'm getting 676,000. 676,000 different license plates. Is that enough for the cars in California? I have no idea. How many cars are in California?
There's a lot of people in California.
There are. And they all have 3 cars. Some do. All right. Anyway. Is that good there? Decisions and options. The model of the car you're thinking of buying is available in 9 different colors and 4 different styles. How many ways? So 9 different colors, 4 different styles. Just multiply. Piece of cake, right? Right? That's easy. You got it. You first decision, what color? Next decision, what style? Multiply together. Piece of cake. Let's move on to something harder. Okay. If there are 8 records to select from, in how many ways can the program for this segment be arranged? Do you understand what they're saying, first off? They're saying it kind of funny. They're saying a disc jockey, he's going to play 6 records, and there's 8 records to select from. So in other words, he's got a box with 8 records in it, and he's going to pick one of them and play it, and then do a second one and play it, and third one and play it, and go on. He's gonna play 6 different records out of the 8. So, what do y'all think? You understand the game plan, right? You know what I'm going to say? Make it real. It really helps. Picture yourself. You're the disc jockey. Think with me. You're the disc jockey. You look down, you've got this box with 8 records. Let me draw that. So you got this box with 8 records in it. You're thinking, why do I have records? This is the 21st century. There's no more records. All right, you're an old-time disc jockey with 8 records. So, and you're looking down and you're saying, all right, I got 8 records in this box. I'm going to play a song first off. And I got to pick a record. How about record number 3? Whatever. Okay? I'm being real now. I'm doing it. And then I've got to play a second song. All right, how about record number 5? Whatever. Then I got to play a third, so I got to do 6 records. I got to play 6 records. The record number 7, okay. Record number 2, okay. Record number 4, okay. One more. Record number 1, whatever. There we go. I played 6 records. Now think back. Decisions and options. See, I tried to act it out. I tried to do it. So think back. How I made 6 decisions, didn't I? For my first decision, in which I chose record number 3, how many options were there? 8. There was 8. I could have picked any of the 8 records, huh? Good. You guys are getting it? That's right. Now, for my next decision, yeah, because I don't want to play the same record again. That wouldn't go well for the radio station. There's 7 options. And then for your next decision, how many options? Yeah, and it just keeps going down by one because you can't repeat any of the old records, huh? It's almost, but it doesn't go all the way to one, does it? Oh, it's P. Yeah, it's exactly that. By the way, yeah, look what it is. It's out of 8, pick 6. That's exactly what it is. If you want to just do 8P6, boom, done. That's what the P is for. Do you see why we learned the P? And we'll see why we learned the C thing in just a minute. I'll tell you how that's different. But that's what P stands for. Is it's technically permutation, which means order. Put in order. Order matters. So to permute means to switch the order of. That's what permute means. So they're saying the order matters. That's going to be a big deal in a second. We're going to talk about when order matters and when order does not matter. But for now, order matters. How do I know order matters? They said arranged. He's arranging the songs. So yeah, that's 8P. And if you want to just save some time and just go, look, it's 8P6. Hit the buttons on your calculator. That's exactly what it is, right? Because remember what I told you? It starts at 8. It does 6 numbers. That starts at 8, does 6 numbers, doesn't it? That's 8P6. Out of 8, pick 6. Permute 6. And what is somebody got a number there? 21,000?
No, 20,160.
20,160. Let's type that in and make sure. All right, let's try another one. Mrs. Welch and her 4 children are shopping at a local grocery store. Each of the children will be allowed to select 1 box of cereal for their own from the 9 different boxes of cereal available. There are no 2 the same. In how many ways can the selections be made? All right. So let's save some time. So with the P thing, out of what that number here is what you're picking out of. P, pick, permute, whatever. What's a better way? Let's do this. Total amount, number picked. How about that? Is that better? Total amount, number picked. So it's out of this many, pick this many. Okay, yeah. Out of how many? So out of how many boxes are the kids going to pick? How many total options? 9. Out of 9 boxes, pick. Make that a little better. Out of 9 boxes, pick. How many are being picked? 4. Out of 9, pick 4. That's what we're basically saying. Out of the 9 boxes of cereal, we're going to pick 4. We're going to pick 4. So 9P4. So you can do that on your calculator. I'm getting 3,024. That's a lot, isn't it? There's 3,020. There's over 3,000 ways the kids can pick their cereals? Yeah. These things add up real quick. Let's go here. Okay, so Mrs. Welch, 6 children shopping. Each children allowed some 1 box from 10 different boxes. That's the same problem? That's dumb. All right, let's move on.
They do or don't?
They do on this one. Look here. It says formula, use NPR. They're telling you. Use NPR. Club with 9 members is to choose 3 officers. President, vice president, and secretary, treasurer. Blah, 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 blah. Who cares? So out of how many, pick the number that you pick.
9.
So out of 9, pick 3. Easy, huh? Out of 9 people, pick 3 to be president, vice president, and secretary. 504? 504 different ways to choose who's going to be president, vice president, and secretary. Out of 9 people. Out of 9, pick 3 to be your officers. Well, to be your president, vice president, and secretary. Now, we're about to shift gears. And they're going to become a C question. So let me just give you a heads up right now. If they said, well, let me see, maybe they said, okay, so we answered the question. What is this problem doing? Here, let me put it in there again. Wait, that's the wrong one, huh? There we go. Okay, let's go back to this question again. All right. President, right, so out of 9, back to the 9. So out of 9, pick 3. We got our answer, whatever that is. 504, right? Okay, now let me change the question. This is, we're picking a president, a VP, and a secretary, right? What if instead they say you're going to pick 3 board members, and they're all equal? Like one of them's not the head of the other. There's not a president and a vice president. They're just all board members. We just need 3 committee members to be part of this board. They all have equal power. You got 9 people. What if I said 9 people choose 3 to be board members? Over here it was 9 people choose a president, a VP, and it's 3 that are president, vice president, secretary. Over here it's choose 3 that are board members. Would that be the same thing? No. Now order would not matter. Let me help you with that. I'll maybe make it as real as I can for you. We got 15 minutes. All right, I can make this real. What if I said, hey, I'm in a generous teacher mood today. I'm gonna take my wallet out. I got a $20 bill, I got a $10 bill, and I got a $1 bill. And I'm just gonna pick 3 names at random. Just gonna pick 3 names. I'm gonna take the roll sheet here. Here we go. I'm going to pick 3 names, boom, 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 at random, and I'm just going to pass out the money. Right? Okay. I'm going to pass out a 20, a 10, and a 1. Ready? First name, Joel. Joel, it's a good day for you. 20. And then Destiny, 10. Right? Okay, so now, what if, would Joel and Destiny care if I had switched that order? If the first name was Destiny, then Joel. Well, yeah, because they're getting different things. Because the rewards are different. Like president, vice president, secretary. Order matters. You care what order. Whereas now, let's do this one where they're all the same. If I say, hey, I'm feeling generous, I'm going to pass out 3 $10 bills. 3 $10 bills. Here we go. Joel, Destiny. Do they care whether I'm a Destiny, Joel, Destiny? Everybody's getting a $10 bill. No, nobody cares about the order when the rewards are the same. You see, when the offices are the same, the order doesn't matter. Who cares? There's no difference. You know, if we had these people, like, I don't know what their names are. If we said, Susan's going to be the president, and Mark's the VP, and Joe is the secretary, versus if I said, okay, it's going to be Joe, Mark, yeah, let me put it right here. Joe, Mark, and Susan. That would be a different setup, right? This result would be different than that result because this is president, vice president, secretary, president, vice president, secretary. Those are different results, aren't they? Whereas over here, if I go Joe, Mark, Susan, or I go Susan, Mark, Joe, who cares? Those 3 are on the committee. We don't care what order they were picked in. They're on the committee. Right? Y'all seeing what I'm saying there? So when they're equal offices, the order does not matter. Come on. Order does not matter when the equal offices. Right? The order matters not when they're equal offices or equal money amounts or equal whatever. When the order doesn't matter, you know what that is? That's 9C3. And this one over here was 9P3. That's the crucial difference between P and C. P is permute. That means switch the order. That means the order matters. So the P order matters. The C is for when order doesn't matter. So let me summarize that a little cleaner. So you use NPR when order matters. You use in, and when does order matter? When the offices are different, right? Like president, vice president, secretary. And you use in CR when order does not matter. Does not matter. That'd be like offices are the same, 3 board members. Doesn't matter what order they're picked in. They're all the same. All right? That's the big deal, which they're going to try to show us in the rest of this section. Okay, so committee of 5 students is to be selected from 13 students in a fraternity. In how many ways can this be done? So we're gonna select a committee. So a 5-student committee. Ask yourself, are the offices different? Offices are not different. They're the same, right? It's not saying we're selecting a president, a vice president, a secretary, and a whatever. They're just saying 5 people. So it doesn't matter whether you pick Joe marry Susan or Susan marry Joe, right? Who cares what order? Order does not matter. Order does not matter. That means, right? We're just picking 5. Who cares what order? So am I going to do P or C? C. You know, I had a colleague years ago that used to say, C stands for combination. He'd say, hey, when you order a combination pizza, do you ever tell them what order to put them on? On my combination pizza, make sure you put the tomatoes on before the mushrooms and then the olives on top of that. No, nobody does that. Combination, order doesn't matter. It's just all on there, right? Order doesn't matter. Combination, so that helps you. So that means out of 13, you always put the big number first, right? Out of the big number first. 13, C5. Out of 13, choose 5 where you don't care about the order. Get the calculator, hit the buttons, let's see what we get. Go over to the math and probability, down to NCR. 13, I get 1287. 1,287 different ways to do that. We're going to do part B also, but there's part A. Out of 13 students, choose 5. Out of 13, the big number always comes first when we do the P and the C, right? Out of 13, choose 5. Order doesn't matter. They're all the same office. 1,287 different ways to do that. Part B, in how many ways can the group, that's weird, in how many ways can the group that will not take part be chosen? In how many ways can the group that will not take part chosen? You can start to see where this class was hard for me, right? They ask questions like this all the time, and even trickier, more subtle. I found this class to be challenging and frustrating, but also interesting in the fact that if you thought the right thought, it was just cake. But if you didn't see it right, it seemed impossible. I kind of liked, that's probably why I majored in math. Like, if somebody asks, why did you major in math? I mean, I probably majored in math because I did well in math and it seemed like I'd be a good career for me. But as far as what you enjoy about math, what I enjoy mainly about it is I like a good, clear, logical thought that cuts through confusion. I love to see something in the right, something that looks terrible and difficult and confusing, and you see it a certain way and it's like, oh, that seems neat to me. So this is one of these cases. First of all, that question just seems bizarre. Like, what are they even asking? In how many ways can the group that will not take part be chosen? Not take part?
Why would we select maybe from 13 to 5?
So they're saying, what about the leftover people, right? You're going to pick 5 out of 13. They're going to get to be on this fraternity? Or no, to be on this committee? Yeah, you're going to pick 5 out of the 13. Say, okay, you 5, you're on the committee. Which, okay, and so by doing so, there's an 8 that are not, right? We've also simultaneously, that's the key observation, at the same moment that you picked the 5, you did pick the 8, didn't you? When you picked the 5, say you 5 are on, what are you saying to the 8? Wait and see. No, you're not, right? When you picked the 5, you picked the 8 to not be. So when we say there's 1,287 different ways to pick a 5, say, okay, you 5, or you 5, or you 5, or you 5, or you 5. There's 1,287 ways to pick a group of 5 to be on the committee. Well, how many ways are there to pick those who will not be on the committee?
Same.
You see it now? It's the same. Because every time you pick 5, you're picking 8. We don't need to do any new calculations. It's 1287.
You know, if you do 13C, 8.
Yeah. How about that? Good observation. You're thinking, well, can't we, you're probably like, I see that, Mr. Chair, but can't we also just say out of 13, choose 8? Right? Because out of 13, if you pick the 8, isn't that another way to do it? Absolutely right. And you'll get the same exact answer. And we see an important observation about C. These are the same. And what is 13 minus 5? 8. So with C, it doesn't work for P. But with C, if you subtract these and put the difference in the second number, keeping the first number the same, those answers are always the same. Always. Because logically, they're the same. If you have 13 people and you pick 5, you have picked 8. Or if you pick 8, you've picked 5. I like that. I like that logic. What I like about math is as long as you think well logically, math will take you there. It doesn't care about style. It doesn't care about looks and dumb, lesser important things. It cares, are your thoughts right or are your thoughts not right? If your thoughts are right, you can go whatever style you want. You can do it this way. You can do it that way. They're both logically true. And so they both arrive at the same conclusion, don't they? Yeah. Good. So here we go. I'm getting too long-winded. We got 3 minutes. All right. How many different committees can we form? We got 6 teachers, 40 students. We're picking 3 teachers, 2 students. It's a couple of C's. I'll just go quick here. Out of 6 teachers, pick 3. Out of 6, choose 3. Times, remember we multiply things we do. Out of the 40 students, choose 2. There you go. Just work that out. See what I did there? We're picking a committee. Out of the 6 teachers, we got to pick 3. Out of 6, choose 3. And out of the 40, choose 2 students. And you times those together. We're always multiplying when you do more than one thing at the same time like that. Is that good on that? So 6, is this 20? The first one, 20? Yeah, and then the second one is 780. And so that's some big number. It's 15,600. There we go. 15,600 ways to do that. See why you use C there and not P? Nothing in that made order matter. The 3 teachers, they weren't president, vice president, secretary or something. It was just 3 teachers. 2 students. Right? Equal offices, use C, not P. All right, 5 questions. Okay. All right. So 29 flavors, 7. They're saying here, order matters. So you care whether you have the chocolate, the vanilla, then the strawberry, or a strawberry in the bottom. Then, the order matters. So if order matters, what does that mean I'm going to use? C or P? P. P. So out of 29, pick 7, huh? And then I imagine part B will say order doesn't matter on that one. Well, that's about all the time we have. So I'm going to stop there. Hopefully